Our project is part of the I-4350 Capstone class taught by Dr. Jamie Rogers and is taking place at Kleinstuhl in Mansfield, Texas.
So this is the overall of our project. Established in 1857, Kleintool is a respected American company known for manufacturing a wide range of hand tools and equipment tailored to professionals in sectors such as construction, electrical work, and telecommunication. Their product line includes essential tools like pliers, screwdriver, and wire stripper. In this project, our focus will be on improving the production processes for screwdriver blades, especially the bolstering and fitting operation, because of the output of this operation has consistently fallen below target rate.
In the define phase, we establish a problem statement. The current production methodologies exhibit inefficiencies and suboptimal throughput rates. Therefore, our objective consists on employing the make process methodology and other IE tools to improve efficiency within the bolstering and finish operations on the bolster blades. Currently, when the process starts, the blade is retrieved from initial polish, then later placed in bin within the bolstering queue and retrieved from the bin by operator. Later, it is determined if it's defective or not. In the case that it isn't, bolster indents are created with press. Then the bolster is manually placed on the blade and then is secured onto the blade via hydraulic press. Then, when the bin is full, it is transported via forklift to finning queue. When it arrives to the finning station, it is received from the bin by the operator. Later, it is determined if it's defective or not. In the case that it isn't, the operator places copper spacer on the blade. Then, the blade is placed in finning press. The spacer is later activated, and the fin blade is placed in the bin, waiting to be transported via forklift to the copper melt. And that concludes the process of the bolstering and finning operations.
After conducting time study for the bolstering and fitting station, we noticed some important things, such as at the bolstering station, the operator takes more than 13 seconds to add the bolster to a screwdriver blade. This means they only make around 259 bolster blade per hour, which is much less than the target of 525 units per hour. For finning, it takes about 21 seconds to fin one blade, resulting in around 227 blades per hour, less than the expected 376. This means the bolstering process only reached 49% of what it's supposed to, and the finning station reached 6% of each production target.
So our analysis phase consisted of investigating the standard deviation of the various processes, conducting a root cause analysis, which consisted of 5 whys for both, as well as fishbone diagrams, and finally we constructed a value stream map to investigate which activities were value added. Our investigation into the standard deviation of the subprocesses revealed there wasn't significant standard deviation within bolstering, but within finning we found that grabbing handfuls of blades for staging, as well as copper threading had a lot of standard deviation within them. For our root cause analysis with the 5 whys, our root cause with bolstering for the inefficiencies was discovered to be faulty and missized bolsters, as well as a lack of adjustability within the workstation itself. Our root cause analysis for finning revealed that the root cause of the inefficiency was an inefficient layout and prohibitive machine construction, as well as the copper threading step, which was a consistent complaint. For our value stream mapping, we found that for bolstering, only 32% of the processes were comprised of value-added activities, and for finning, likewise, we found that only about 38% of the processes was comprised of value-added activities.
In the improved phase of our project, we will create standard work instruction charts for both stations. At the bolstering station, we aim to reduce double handling by staging the bins closer to the operation at an appropriate height that prevents straining movements from the operator, as well as having the workers use one hand to grab a new blade at the same time they use the other to move the finished blades to the receiving bin. At the finning station, we will allow double handling to stage the blades closer to the machine as it is difficult to bring the bins as close as necessary. We will also reduce the time wasted on placing the copper ring around the blade before finning by having a machine operator doing during their idle time or using a rolling copper ring station to make the operation less tedious. Finally, on the larger scale, we will explore the option of redesigning the layout to promote a more streamlined production flow within and between both stations.